complete question of simple harmonic motion, which reads that a tube closed at one end has a constant area of cross-section capital A. Some lead shots are placed in the tube so that the tube floats vertically in a liquid of density ρ, as shown in figure 1 below. Figure 1, can you see there are lead shots shown? Surface of liquid is shown, tube of cross-section area is shown and liquid of density ρ is also shown. Total mass of tube and its contents is capital M. Tube is oscillating up and down and its vertical acceleration small a is related to its vertical displacement y by the expression A is equal to negative A rho g over m multiplied by y. Now the question part A asks you to define simple harmonic motion. I have already given you lectures on the chapter of simple harmonic motion. However, for your revision, I am writing the definition once again. Simple harmonic motion is one in which acceleration of the body performing simple harmonic motion is directly proportional to its displacement from the mean position, and the acceleration is always directed towards the mean position. If you write these 2 points, you will get full marks, but if you write only 1 point, you will get 1 mark. So you have to remember this definition by heart and understand that as well, which has been explained by me in my lectures earlier. Part B of the question is that you have to show the frequency of tube is given by the formula F is equal to 1 over 2 pi root A rho g over m. Now, in order to bring frequency into the formulae of acceleration, we already know that acceleration is equal to minus omega square x. Here x is equal to y because he has given in the question that displacement is y. So we can write down A is equal to minus omega square y. And if you look at the question, he has also given another equation of A equal to minus A rho g y over m. If we look at these equations, there are 2 equations of acceleration available. In these 2 equations, left hand side is same because left hand side is A. So we can say that right hand side will also be equal. So we equate them, and when I equate them, I go to the red part of the solution. Minus omega square y is equal to minus A rho g over my. Y and y gets cancelled. Minus sign on both sides of the equation get cancelled, and we also know that omega is equal to 2 pi f. So I put 2 pi f in place of omega. So 2 pi f whole square is equal to A rho g over m. Now if I take under root on both sides, the square of 2 pi f will be gone and there will be under root coming on to right hand side, and I'll get 2 pi f is equal to root A rho g over m. I make f the subject of the formula. 2 pi goes on the other side, and this is the formula that he has asked you to show, and we have shown that. Then going to part C. I have hand drawn the sketch of variation of y with respect to time t in figure 2 below. And this variation is in another liquid. Y is on the y, that is displacement, is on the y-axis in centimeter, and on x-axis we have time in seconds. If you look at it, from time we can find out time period, and from y we can find out the amplitude, etc. Going on to first part of part C, external diameter of tube is 2.4 centimeter, and if it is floating in a liquid of density 950 kg per meter cube, and assuming the equation in B is applicable, calculate the mass of tube and its contents. My dear students, the English of the question, which is also known as word problem in mathematics, you have to remember that the information given in this paragraph and information given in any paragraph of the word problem, you have to remember that, or you write it down on the left hand margin or right hand margin of the page with pencil so that you don't forget. Now in part 1 he has given you that you have to use the equation that has already been done in part B. So I write down equation 2 pi f is equal to root a rho g over m. Right. So now I have to calculate m. There could be two methods of doing it. First of all, I could do what I could do was that I could make m the subject of the formula first and put in the values. If that is to be done, I will square both sides and I'll get 2 pi f whole square is equal to a rho g over m, but I have done this otherwise. And what I have done is I have first of all written t is equal to 1 over f, so f is equal to 1 over t. 2 pi f will become 2 pi over t equal to root a rho g over m. I put in the values. Time period I have taken from the graph above, figure 2. Can you see that the time period is 0.6 seconds? I have taken that and put in the values 2 pi over 0.6 in place of t, and then I had also to calculate the area. Can you see that he has given area, diameter as 2.4 centimeter, and the area can be expressed in terms of diameter. It can also be expressed in terms of radius. I have done both for you. Area is equal to pi d square over 4 in terms of diameter, put in the values. And when you are putting in the values of d, you must remember that you have to change centimeter into meter. So, to change centimeter into meter, you have to multiply it with 10 power minus 2. And if you want to use pi r square, then you have to divide the diameter by 2 and put in the values, which is 1.2 into 10 power minus 2. Both of the values are same, that is 0.00452389. I have written it in standard form while putting the values in the formula 4.52389 into 10 power minus 4, and then use the calculator. But you see, if you want to do it this way, squaring both sides, there is no problem. However, what I would suggest is that you also have to keep in mind the space available for the solution of the problem. So there are so many steps that you can forego and put in the major steps that are required to score 3 marks. So when I work it out, it comes out to be mass is equal to 3.84 into 10 power minus 3 kg in standard form. You should always try to write the answers in standard form, and also keep in mind the number of significant figures that have been used in the data, so that no mark is lost by you. In part C, he has only asked you how we can say that oscillation in figure 2 are damped. The definition of damping is that the amplitude of the wave or amplitude of the oscillating body reduces as the time passes. The figure 2 is showing that the amplitude is reducing as the time passes, so we can say that the oscillations are damped. And although this is not part of the question, but damping, damping occurs because of the friction of the medium in which the body is oscillating. In this question, the medium is the liquid in which the cylinder is oscillating. I hope you have understood. I will be uploading more questions with different word problems, with different requirements, so that the topics are clear to you, and at the same time revision is done by you with me, and the subject is made easy. Kindly like my channel and subscribe